Adjoint of a matrix. The adjoint of a square matrix A, denoted by ADJ of A, is the transpose of the matrix of cofactors associated with every element of the matrix A. Now here you see we've mentioned some key terms here, or keywords. Now the first thing we should take note of here is this, that adjoint is only defined on square matrices. So if the matrix is not a square matrix, we can't define the adjoint. That's number one. Number two is the notation ADJ of A. So if we write ADJ of A, that would mean adjoint of A and not adjective of A. I'm just joking. The next term here is transpose, which you already know. I'll still explain it later on. And the next thing is the cofactors, and that's it. Now let's get straight to it. Let's assume we have a matrix A, our general 2 by 2 square matrix, with entries A11, A12, A21, and A22. Now, this matrix has 4 entries, 1, 2, 3, 4. Therefore, each entry of this matrix has what they call a corresponding cofactor. So if I write A11, if I write C11 to be the cofactor of the entry A11, it will now mean that C12 will be the cofactor of what? You can guess, of A12, and then C21 should be the cofactor of what? The entry A21, and C22 should be the cofactor of the entry what? Of the entry A22. So for a 2 by 2 square matrix that has 4 entries, there will be, which I also have 4 cofactors for each entry. So a 3 by 3 square matrix will have how many entries? Will have 9 entries, and so we're going to have 9 cofactors. Now the question now is, what is a cofactor? Now, the cofactor of A, look up. Now the first thing you're going to do is this. Put your signs, say plus, minus, put here, minus, and plus. Just ensure that the same signs do not stand do not stay next to each other. So if here is plus, here is minus, plus, minus, minus, plus, just like that. This will save it some time. So the cofactor of A11, which is C11, so the cofactor of A11, which is C11, is equal to what? The first thing you look at is the sign. What sign is with A11? Is plus. So that will be plus times the minor of A. I'll explain what minor is in my very previous video on determinant of matrices. Let me repeat what minor is here. Now the minor of this entry A11 is what you get when you delete the row of A11 and the column of A11. So what do you get by doing that? Now when you delete the row of A11 and the column of A11, what do you have left is A22. You have A22. You have A22. So A22 here is called the minor of the entry A11. So the cofactor of the entry A11 is now what? A22 plus A22, which is just the same thing as what? A22. So A11 has its cofactor C11, and what's C11? A22. We can go ahead and find the cofactor of the next entry, which is A12. And what would that be? So the cofactor let me use the black ink. The cofactor C12 of A12 would be what? What sign is here? Plus, minus. So this is minus. And then you now take the minor of A12. What's the minor of A12? Delete all the entries in the row of A12. A12 is in row 1. And all the entries in the column of A12. What do you have left? A21. So you have A21 left. So minus A21. So minus A21 becomes the cofactor of the entry of the entry A21. And then next you have the entry A21. So the cofactor of A21, the C21, is what? We'll do the same thing. So we delete the entries on the row of A21 and the entries on the column of A21. But what sign would that be? A21. So this is minus. So this is minus. So what is the A12? Minus A12. And that will be the cofactor of the entry A21. Lastly, the cofactor of the last entry, which is A22. So cofactor of A22, I shall write as C22, will now be, we'll repeat the same process. Delete the entries in the row of A22, which is this row, and the entries in the column of A22, which is this column. And what do you have left? You have this. But what sign? The sign is plus. So this is plus. The minor is A11. A11. Which is just the same thing as A11. So what we now have here, so we have for each entry of this 2 by 2 square matrix, we have a corresponding word cofactor. Okay. Now, we can define a new matrix, which I call the matrix of cofactors. I want to denote that matrix with capital letter C. Okay. That will be what? Now, what's the cofactor of A11? C11, which is A22. What's the cofactor of A12, which is C12, that is negative A21. Cofactor of A21, which is C21, is negative A12, and the cofactor of A22 is A11, is A11. So this is what we call the matrix of cofactors. Now you should recall what the transpose of a matrix is. You know, when you interchange the rows and columns of a matrix, what you now have is a transpose of your original matrix. Now, from this we define the adjoint of matrix A. Now, the adjoint of matrix A, which is AD, small adj of A, is equal to the transpose of the matrix of cofactors. And what's the matrix of cofactors? A22, negative A21, A12, negative A12, and A11. The transpose. How do you transpose? Row 1 is what? A22 minus A12. Now, that row 1 becomes column 1 in the transpose. That becomes A22, negative A21. And then row 2 becomes column 2. So row 2 is negative A12 and A11. That becomes negative A12 and A11. And what we now have here is called the adjoint of the original matrix A, which is the original 2 by 2 square matrix. So how do we get the adjoint of matrix A? First, we find the cofactors of every entry of matrix A. And we got all this. The next thing we now do is we now form a matrix of cofactors. Okay, so A22 is a cofactor of the first entry, of the first entry A11, minus A21 is a cofactor of A12, and so on and so forth. After doing that, we'll now take the transpose of this matrix of cofactors. And the new matrix we're going to have, which is this, is now called the adjoint of matrix A. So the definition, once again, it should now make sense to you. The adjoint of a square matrix that we have here, 2 by 2, denoted by this, is the transpose of the matrix of cofactors, associated with every element of matrix A. I guess it's now very clear enough. Okay, so with this, we shall now take a concrete example of adjoint of a matrix using a 3 by 3 square matrix. Example: determine the adjoint of the matrix A with the entries 2, negative 1, 2, negative 2, 4, and this. Now, matrix A is clearly a square matrix since it's 3 by 3. So 3 rows, 3 columns, it's a square matrix. So we can find the determinant of matrix A. Now, how many entries do we expect in our adjoint, in that adjoint matrix? Now, matrix A has 9 elements or 9 entries. So our adjoint of the matrix will also have what? 9 entries. Next, we know is that each of the entries of matrix A will have its own corresponding what? Cofactor. Good. So after we've gotten the cofactors of matrix A, we'll now put them together to get our matrix of cofactors. After that, we'll now transpose our matrix, and what we get is the adjoint of the matrix. And of course, this is what we use this very much in finding the inverse of matrices, which I shall show you in the next video. All right, so let's get to work. Solution. I want to write out matrix A again as 2, 3, negative 2, negative 2, 5 and 4, 4, negative 2, and 3. Now, if you recall from the illustration using the 2 by 2 square matrices, I've shown you that there are certain signs that must go with every cofactor, right? And I gave a simple way of fixing those signs. So I'll just start with plus here, minus, and plus. Remember, the same sign should not follow itself. So this is plus. Here will be what? Minus. Minus here will be plus. Here will be minus. Here will be plus, minus, and plus. With that, we're good to go. So these are the signs that will follow, your minus. So let's get started. So recall that this entry here is A11, right? This is the entry that corresponds to, this is the entry in row 1, column 1. So that's A11. So we want to denote its cofactor as C11. So the cofactor of A11, which we want to write as C11, so that represents the cofactor of the first entry A11. I hope it's clear. Okay, so what would that be? First, the sign. What sign would that be? The sign is positive, so that would be plus. Since it's already plus, I need to write it, no need. I'll just let it go. The next thing is, in fact, let me just write it, plus. The next thing is I'm going to multiply this sign by the minor of this entry A11. And what's the minor? The minor of A11 is simply what we get after deleting the element of the rows of A11 and the elements of the column of A11. What do we have? What we have there is a 2 by 2 determinant. You should recall that the minor is determinant. So this is, we have here 5, -2, we have here 4 and 3. What would that be? That becomes, so the determinant of 2 by 2 matrix will be what we multiply the entries of the diagonal, 5 times 3. So this is 5 times 3 minus 4 times -2. So 4 times -2. And that gives us 5 times 3 is 15 plus 8. And what is that? That is 23. So our very first cofactor, which corresponds to the first entry A11, which is C11, is 23. So we'll go ahead to get the second cofactor for the next entry A12. So this is A11, A12. So we call that C12. So C12 means the cofactor that corresponds to the entry A12. So that will be what? So again, we fix the sign. What sign would that be? This is plus, this is minus. This has to be minus. Then we multiply that by the minor of that entry. So we clean this other line and get the minor of the next entry. So this entry here is in row 1. So I delete all the row 1 entries, and in column 2, I delete the column 2 entries. So the minor now becomes the 2 by 2 determinant that is there. What is that? 3, -2, -2, and 3. So that's equal to minus into, let me leave it like that. So 3 times 3 is 9, minus 2 times -2 is 4, -4. That is minus into 9 minus 4 is 5. So minus 5. So our second cofactor, which corresponds to this entry, is -5. So let's take the next cofactor, which is for the third entry, A13. So C13 is a cofactor that corresponds to the entry A13. First is a sign. What sign should that be? Plus. We fix our plus there and take the minor for that entry. So again, you delete, clean our line and take a fresh one. So this entry is in row 1. So I delete the row 1 entries, and in column 3, I delete column 3 entries. And what do I have left? The determinant there is 3, 5, -2, and 4. And that would be, this is plus already, so 3 times 4 is 12 minus, this minus come with the formula. Minus -2 times 5 is -10. So this is plus 10. So 12 plus 10 is 22. That is our next cofactor. So we go on to the next one. So we're done with the first row. Second row, this is now A21, the entry in row 2, column 1. So C21 will be the corresponding cofactor. What sign should that be? Minus. We fix the sign first, then the minor of that entry. So I take off my line again. I hope you're following. Take off my line. Now this entry A21 is in row 2, I delete, and column 1, I delete. What I have left becomes a minor for that entry. So I have here -2, I have here 4, I have here 4, and 3. So the determinant is minus. I put the minus out there. So -2 times 3 is -6, minus 4 times 4 is 16. So minus into -6, so -6 minus 16 is a -22. So minus times -22, this is nothing but what? 22. So that's my next cofactor. So the next cofactor is A22, which I write as C22. What sign should that be? Positive sign. So I'll just let it be. Then take the minor of that entry. So I'll delete again. I won't get tired of deleting until you understand what I'm doing. So the entry for A22, this is the entry A22, is in row 2. I take it off, and column 2, I take off. What I have left is my minor. So 2, 4, negative 2, and 3. Determinants. So 2 times 3 is 6 minus 2 times 4 is minus 8. So that becomes 6 plus 8. And what is that? 14. That's the next minor. The next cofactor rather. The next one is for C23. So we want to use black ink here. So C23, which is the cofactor for the entry of row 2, column 3. So this is entry of row 2, column 3. A11, A12, A13, C821, A22, A23. So that becomes, so what sign should that be? Negative sign. So minus into, now the minor of that entry is what? I take it off again. I'll take the minor. This entry is in row 2. I take off. Column 3. I take off. So what I have left is the minor. What is that? That is 2, minus 2, minus 2, and 4. So determinant is minus. Be careful with it to guide along. So 2 times 4 is 8 minus 2 times minus 2 is 4. Minus 4. So that gives us minus into 8 minus 4 is 4. So that is minus 4. That is our cofactor. The next cofactor is for A31, the entry in row 3, column 1. So I shall call that cofactor C31. What is the sign? Positive sign. So I just let it go. And what's the minor for that entry? So once again, remember we cannot get tired. So that entry is in A31, row 3, column 1. So row 3, I take off. Column 1, I take off. And what I have left is my minor. So I have minus 2, I have 4, I have 5, and minus 2. Okay? And that will be minus 2 times minus 2 is 4, minus 5 times 4 is 20. So that 4 minus 20 is negative 16. That's my cofactor. The next cofactor is for A32. So that is C32, the cofactor for the entry in row 3, column 2. Okay, what sign should that be? That should come with a negative sign. Negative sign, so I put here my minus times what? The minor of that entry. So what is the minor of the entry? I come back here. Now that entry is in row 3. So I delete row 3 entries and column 2. I delete column 2 entries. What do I have left? 2, 4, and this. So I have 2. I got 4. What else? We have 3 and negative 2. All right. So what is that determinant? Let's see. This is negative into 2 times negative 2 is minus 4, minus 3 times 4 is 12, minus 12. So that becomes minus into minus 4 minus 12 is minus 16. So minus times minus 16 is 16. That is the cofactor. And we have one last guy to compute. So the cofactor of the last entry, which is A33. So the cofactor there is C33. And what would that be? What is the sign? Plus sign. Positive. So I'll just let it be. Times the minor of that entry. So for the last time, I take off my fine lines. Now the entry A33 is in row 3. I take off row 3 entries and column 3. I take off column 3 entries. And what I have left is my minor for that entry. So I have 2, negative 2, 3, and 5. Okay. So determinant 2 times 5 is 10 minus 3 times minus 2 is minus 6. So that becomes plus 6 equal to 16. That is the cofactor for the last entry. What have we done so far? So far, we have been able to get the cofactor or the cofactors of each of the 9 entries of matrix A. Good. The next step we're going to take now is to put all these cofactors into one matrix. We shall call that matrix the matrix of cofactors. So I define a matrix, a new matrix, matrix C, which will also be a 3 by 3 square matrix, because if matrix A is 3 by 3, then its adjoint will also be a 3 by 3 square matrix. So matrix C, which is the matrix of cofactors, is, now the cofactor for A11 is C11, which is 23. The cofactor for A12 is negative 5, so negative 5. The next one is 22, so I'll just fill it up. So we'll put down the cofactors corresponding to the entries. So A21 is 22, A22 is 14, A23 is negative 4, A31 is negative 16, A32 is 16, and A33 again is 16. So what we now have here is what we call the matrix of cofactors. As you can see, each entry of this matrix corresponds to the cofactor of its corresponding entry of the original matrix A. The next thing we're going to do is to transpose this matrix. And once we transpose this matrix, the new matrix we're going to get is now called the adjoint of the original matrix A. Okay, so I now write another matrix, C transpose. Don't mix this up. C transpose. So C transpose means I should transpose the matrix of cofactors. What does that mean? That I should interchange my rows and columns. So row 1 shall become column 1, and row 2 becomes column 2. What's row 1? 23 minus 5 and 22. So that becomes column 1. So 23 minus 5 and 22. Row 2 is this, becomes column 2. So 22, 14 and minus 4. Row 3 becomes column 3, negative 16, 16 and 16. So this matrix now is the transpose of the matrix of cofactors. It is this matrix here that is now called the adjoint. This matrix is now called the adjoint of matrix A. So in our next video, I shall show you how we use this adjoint of matrix of a square matrix to determine the inverse of a matrix where the inverse exists. I guess you understand the video. Please do leave a comment and like on this video. Thank you and bye bye for now.